Hey there. Okay, so I'm trying something a little bit different today. I embedded my webcam because I'm going to do I'm going to do a lot with my hands, especially when we talk about a present value of an annuity. So we've already talked about annuities. Those are payments that are made at equal intervals of time, um, equal amounts over equal intervals of time. So what we've talked about already was future value problems. Those are where you put money in equal installments and you get money back at the end. So it's like investments. So you're putting in, let's say, $100. Well, the grandma situation, $1,000 every year on your birthday. You do that for 18 years, and instead of having $18,000 on your 18th birthday, you accumulated interest over those 18 years. So you might have, $24,000, $25,000 because it earned interest over those 18 years. So present value problems are where you put money in equal installments and then you get back money in the future. If you look at this scenario, here you're still making equal payments over equal intervals of time, but notice where the dollar sign is. It's now in the present. So what you're doing is you're basically taking money right now, borrowing it essentially, and then paying it back over however many increments that you want over the future. Those are present value problems. The most common ones you're going to see are loans, mortgages, car payments, those kind of things. Okay. So these are kind of big ticket items that you want. So cars, appliances. You want to negotiate a payment plan with whoever you're borrowing this money from. One of the things that is negotiable, whether people tell you this or not, is the interest rate. So if you walk into a bank and say, "Hey, I want to buy a $50,000 car," they're going to say, "Okay, well then we'll charge you 5.5% interest for the next 4 years to pay off that car." If you know that your friend, bought a car from a different institution and they offered him 3.5%, well, you have negotiating power. So don't ever think you don't. Go in with, strong, firm, and say, you know what, I know for a fact I can get a lower interest rate at bank number two. So either you give me what I want or I'm going to go to them and give them my business. And they will cave most of the time. As long as you're being reasonable with your negotiations. So please think about that. You don't have to do exactly what they tell you. In fact, the other thing you don't have to do is you don't have to lock yourself into compounding your payments annually. You could compound them more frequently. Now, remember in the last class, we talked about when you were investing money, you wanted to invest money and get a higher interest rate because you're getting more of that. You're getting that interest, right? You're pocketing that money. But in this scenario, in a present value scenario, you don't want that interest rate to be high because you're paying that interest. So that's more money coming out of your pocket. So try to make that as small as possible and try to pay it off as quickly as possible. Because what's going to happen every time you make a payment? So let's say your payment was $500 a month. You give them $500 a month. That's all you know. $500 came out of your pocket. But what's happening on the other end is that $500 is getting broken up into two parts. One of those parts is the money that's going to directly pay off the item that you bought. So the car, the house, whatever. The other part of your $500 is going towards interest. That is money that they are pocketing from you. Okay, so you don't know what that proportion is, that $500. It's not 50-50. So it's not like $250 goes towards the car and 250 goes to interest. It's more like, well, actually, it depends on how long your loan is and what your payment amount is. So I can't even give you it's 80-20. There's no real general rule of how much it is. It's just broken. And as time goes on, so if I kind of do this with my hands, right now, here's 50-50 split. So 250 goes to the item, 250 goes to the interest. But after time, that gap between the two becomes greater. And so more of your money that's coming out of your pocket is going to pay off your item and less of it's going to pocket to give them interest. Okay, and that's to your benefit. So when it's like this, it's not to your benefit. Even when it's like this, but eventually when it gets like this. So I'm going to actually show you a spreadsheet. I think this will help you see what I'm talking about visually. So take a look here. This is just a generic spreadsheet for a loan. Now this happens to be a $300,000 loan. Let's just lower that. We'll talk about this loan in the mortgages lesson. But for a car, so a car, let's say, well, we said 50,000. That's pretty unrealistic. So I'm going to say like $30,000 car. So there's a $30,000 car. Now, right now, I've got me paying off the car at a 6% interest rate, which is a little high. I'm going to lower that to, right now, I believe the interest rate is 3.8. So let's use it 3.8. Now, I'm not taking 20 years to pay off a car, and you should never have to. So, but actually, if I leave the 20 years and I'm telling you I'm going to pay off that car in 12 installments per year, that's basically saying I'm paying them monthly, which is the most common way people pay off cars. Nobody's going to let you pay it off annually, so it will be a monthly payment. Now, take a look in the green section here, 178.65. That is the actual dollar amount that you are paying out of your pocket to the bank that lent you the money. That's not that much money, actually. That's 178 bucks a month but look, that's you're doing that $178 a month for the next 20 years. So what's interesting here is look at this total interest paid. That means over 20 years, even though you bought a $30,000 car, your car ended up actually costing you $42,875. Okay, because you paid them $12,875. You just gave them $12,000 on top of what the car was worth. Why? Because that's what we call the cost of borrowing. Okay, your cost of borrowing is crazy high. Nobody's gonna, that's almost half the value of your car. So I wouldn't recommend doing that. So what should we do? We can lower the number of years, but what's gonna happen? So most people pay off cars in 4 years. Now this might not be, okay, that's not unrealistic. There you go. Now, if you drop that number of years to pay off your car down to 4, look what happened. Yes, your payments went up. So now they're not $128 payments, they're a little higher, 674. But look at this number. Now all you're doing is giving them $2,385. That's like your thank you. Thank you for lending me money. I really wanted that $30,000 car. So here's a $2,385 tip. That's kind of like what you're doing, right? So now your car right here, even though it was a $30,000 car, you paid them in total $32,385. Okay, so you paid them some amount for the car plus a little bit more, and that little bit more is very reasonable. Okay, to borrow money for 4 years and only have to pay them $2,000 after is actually very reasonable. The $12,000 interest was not reasonable, and I would highly discourage you from ever even thinking about doing that. But I wanted to show you what I was talking about when I was doing this with my hands, okay? So if you scroll down, I'm going to scroll down actually, okay? So in, hold on, I can't go down. Oh, okay, so I'm not being able to move that down. So this is called an amortization schedule. Amortization is just a fancy word. It's actually got a French root, I believe, to its word, which means to disintegrate or to kill off a mortgage or a payment. So it's basically where you're watching that principal. So if you look over here, the principal right now is 30,000. That's how much you borrowed. And every time I go down, that number is going down because, of course, what's happening? You're paying money down on your, so payment number, 5 over here. That means on the 5th month, you gave them $674.69, of which, look how they split it up. Remember I told you how they split it into 2 parts? It's not equal. Okay, so $587 of your $674 that you gave them went directly towards the car that you bought. But $87 of that $674 payment went towards interest. So that's a big gap, right? More of it's going towards your principal, which is to your benefit. That's good for you. Okay. And then as you go down this list, look at the numbers, look what's happened to the numbers. Let's just jump down to payment number, 45. Okay, much better. Look at this. You only owe $2,000 left of your 30,000 bill. You're at 45 months. So just under 4 years, right? You've got 3 more months left. You're at 3 years and what is that? 3 years and 9 months that you've been giving them $674, $674, $674. You're now 3 months left of the payment, and look what you're at. Of that $674, only $8 is going to them that they're pocketing as tip money, okay, it's interest. But 666 of your $674 is directly being dropped down onto your payment. So what's happened is that number, that gap got way bigger. And so now more of your money is paying off your principal. So that now that we're at the very end, there we go. Literally only $2 of your last payment went towards interest, but the rest of it now, look, your principal zero. So you've diminished your principal over 48 months because 48 months was 4 years. Okay, so I hope that gives you sort of an idea of how loan works and paying it off, and how what money you decide to pay, the payment that you're making, will affect the total interest that you pay in total compared to how much you pay. So what that value actually is. So this, I will often refer to this number here, this total interest paid, as the cost of borrowing. So if I ever say, what was the cost of borrowing? I'm asking you, above and beyond the value of the item, so in this case 30,000, how much did you pay? And so how are you going to get that number? You're going to figure out what you totally paid and subtract it from what you borrowed, and then the difference is that. That's where this number comes from. Okay? So I hope that makes sense. I think what I'm going to do right now is, well, let's go actually just do one example here. Here's a scenario. Okay, so very common scenario, you're going to want to probably go to university in a year or two, and you might not be able to pay your tuition. So if you wanted, so your tuition is going to cost $5,500, let's say, per year, okay? You need to do this for a 4-year degree program. So you need to come up with $5,500 per year. But you don't have that money. So what are you going to do? You're going to ask to borrow it. Now you could borrow it from something like OSAP. OSAP is an Ontario government fund that you can apply for. You're not guaranteed to get it, but you can apply to OSAP and borrow the money, or you can just go to some bank and say, hey, can I get a loan? And so what you're trying to figure out here is, what amount do I need today to borrow so that every year for the next 4 years I can give my university $5,500. So here's sort of the timeline scenario. Okay, it's very similar to what we did with the future value, but notice how with future value we were on the other end. We were saving money because we were getting money later in the future. Well, look at my diagram now. Now I have it in the beginning, in the now scenario. Okay, so what we're doing, we're still making equal payments at the end of each term. So right now, here's today. I'm going to drop $5,500. I know I need to give $5,500 when I register for school at the end of a year, let's say. Okay, that $5,500, this formula right here is the same present value formula. Actually, I'm just going to show you the formula here again. Remember this formula. Okay, 1 plus I. This was your compound interest formula. This is the same formula I'm using, but you'll notice that the exponent is negative. Okay, and the reason that the exponent is negative is because we're actually solving now for P and not A. So when you're solving for P, then you're going to get principal is equal to A divided by 1 plus I to the n. Okay, now if you put 1 plus I to the n, then that's the formula. But if I don't want to have a fraction, I could write it as 1 plus I to the n. But we know exponent laws, when we bring a power from the denominator up to the top, it becomes a negative exponent, and that's where that formula comes from. Okay, so this A times 1 plus I to the negative n is where this formula comes from. A being the amount I want in the future, so there's my 5,500. I want 5,500 at the end of a year. The interest rate is 6%, so I'm adding 6% to 1. And then my exponent in this case is -1 because I want it 1 year from now. And if you plug that into your calculator, you're going to get 5188. So what they're saying is, you need to borrow 5188 right now today, so that in 1 year it will grow. You will have 5,500 to pay to your school. Okay. But you want to be able to do this for the next 4 years. So every year in university, you got to pay a tuition. So what do you need? You need another 5,500 in year 2, right? So let's move this over here and go year 2. How much do I need today so that I have 5,500 in year 2? So all I did was I changed this exponent up here to 2, -2, of course, and that's 4894. Okay, so 4894 is what I need right now so that I could have 5,500 in the second year. And of course, the pattern's going to continue. So in the third year, I need 5,500. So I put that in. That's 46 I need now. And then my last thing for my last year of university, I needed another 5,500, and that's 43.56. Now, what am I going to do to these numbers? Each year, I'm not saying, oh, give me a number right now for next year. I want to have all of my tuition given to me right now today. So for the next 4 years, if I take these numbers and I add them, so let's add these four numbers up, that's $19,058.07. So what that's saying is, if I go to the bank and say, hey, I'm going to university for the next 4 years, can you lend me $19,058? They're going to say, sure. And then what that guarantees by giving you that amount, it guarantees that you will have 5,500 at the end of every year. If they give you more than that, you're going to have more than 5,500. If they give you less, you're not going to be able to make this payment. That's why this number is important to calculate. Now, I mentioned this with the future values. This is a tedious process. We had to do one calculation, then another, then another, then another, and we had to add them all up. This is actually another example of a geometric series, not a sequence. A sequence would have commas, but because I'm adding them, it's becoming a series. If you look on the CEMC website, you will see a really cool explanation. I love that site, I do. But if you go on there, they'll describe to you geometric series and the formula that you would have learned about it, but we don't have time to learn it. So you don't have to worry about the formula for geometric series. It essentially just translates to the one you're about to get right now, okay? But the series is because you multiply by 1.06 every time. That's where these numbers came from. But what if this was a mortgage or something that you were paying off in way more years than just 4? You do not want to do this tedious process. So that's where this formula comes in. Now, okay, so this is very similar to the formula you had for future value, but now I'm going to use PV for present value, meaning what do I need today? R is the same R that it was for the future value question. That's your payment amount. But now take a look at this square bracket. This is a little different than last class, right? Last class, you had the 1 plus I to the n, and then minus 1. This is 1 minus 1 plus I, and then it's to the negative n. But it is all still a square bracket, and it's still divided by I. So just, again, you don't need to memorize the formula. You just have to know how to use it. So let's learn how to use it. All the variables or parameters mean the same thing that they did before, so I'm not going to reintroduce those, but let's just try that same example we just did a minute ago and plug them into this formula, and what we should get is that 19, let me just go back for a second here, what was it? Lost it here, so let's cut this out here. So we should get 19,058 by plugging it in, okay? So, all right, let's double check. So what am I going to say? My PV in this case is the number I'm looking for, so I don't know that number. Okay. My payment, I want to be able to make $5,500 payments, so that's my R or my PMT. The interest rate, now this is saying compounded annually. So again, if it didn't say annually, you would have to do a division, but it is annual, so it's just 0.06, converting the percent to a decimal. And N is the total number of times that you made that payment. And in this case, because you're doing it annually, it's just 4. So you don't have to multiply by anything. You're just going to plug those numbers right into your formula, and you can verify right away, then that number should give you 19,000. So just watch your bed mass, like I said before in the last lesson. And I'll tell you how I would do it. So, oh, why am I putting I in? 0.06. So grab your calculator out and 0.06, and I'll walk you through the steps I would take so that you're doing it all at one shot. So 0.06. Okay, so take your calculator out. Here's mine. Okay, the first thing I'm going to do to make sure I get the right answer is I'm going to do that inner part right here. I'm going to do this 1 plus 0.06. I know that's 1.06. I'm just going to put 1 plus 0.06. Okay, there you go. And then I'm going to raise that number to the exponent of -4. So to the exponent of -4. And I'm going to say equals. Okay. So that number right now is 0.7920936632. I'm not going to write that down. I don't want to waste my pencil ink. So I'm going to take that number. It needs to be taken away from 1. So I don't want to do -1 because that's the that's the opposite. I want to take it away from 1. So I'm going to make this answer negative. Okay, and then I'm going to add 1. Okay, so now I have 0.207906336, blah, blah, blah. That is this entire square bracket right here. What am I going to do to that whole number? I'm going to multiply it by 5,500. Now I have 1,143.484852, blah, blah, blah. Again, I'm not writing that number down. My final step is to take that number and divide by 0.06. And there it is. Okay, so it's the exact same number that we knew we were going to get, 19,058. I'm off by 1 penny, but that's just a rounding error. Okay, so there you go. Try it again. If you didn't get it on your calculator, figure out how your calculator works, and that's the easiest thing you can do for yourself. Okay. Okay, I'm going to I think I wanted to end, I'm not going to do this one with you. I will make a separate video just of this example if you need help, but I'm going to suggest that you try to do the Jenny example on your own. Here's that word I told you I was going to ask you. How much did it cost her to borrow the money? So that's what I'm looking for, is not what's the total amount, but what's the cost of her. So the interest essentially is what I'm asking you there for. I'll make a separate video for this one. I just want to really talk about this scenario. So let's end with this Kate question, okay? Because this is a little bit more complicated than the other ones. Yeah, they're a little bit more straightforward. Question A and B are very straightforward, okay? So Kate's paying $500 every month, and she's doing that for the next 4 years to pay off a student loan. She got a rate of 4.5%. So using the formula, let's list my parameters. So listing my parameters, I'm going to have PV is what I don't know. Okay, my R is my payment, 500 I think it was. So she's paying 500 bucks. Her interest rate is 4.5. Now, is this compounded? Oh, it's compounded monthly. Okay, so what do I have to do? I have to take 4.5 and write it as a decimal, so 0.045, and then I'm going to divide that number by 12. I'm not going to do that right now on my calculator because I prefer to keep it as accurate as possible. So we'll do it later. And then N was how many total payments does she make? She's doing it every month for 4 years. So 4 years, and there's 12 months in a year, which means she's paying 48 times. Okay. So where are we at? Okay. So at this point, I'm just going to take this formula right here, the formula that I have. Can't find it right now. There it is. Okay, so take this formula and I'm just going to plug the numbers in. So I'm actually just going to do it right here. So PV. Okay, so PV is going to be equal to, and you're going to again put 500 in, plug it in. You're going to do 1 minus, round bracket, 1 plus. I'm going to do 0.045 to the divided by 12, all in my calculator at one shot. Then I'm going to raise it to the negative 48. And then I'm going to close my bracket, square bracket, these should have been squares, and then divide that whole answer by 0.045. And then I'm going to use brackets because in my calculator, I really want to make, so please pause the video if you need to and try the BEDMAS steps I showed you earlier. So do the 1.0, do this part first. Actually, do this part first. 0.045 divided by 12, get a number. Add it to 1, get a number. Make that number negative. Oh, wait. Sorry. Yes, sorry. Yeah, raise that number to the negative 48, then make that number negative, then add 1. That's where you're going to get this big square bracket from. Multiply that big square bracket by 500, then divide it by, use a round bracket, put in this number here, 0.045 divided by 12, close your round bracket, say equals, and it should generate a final answer. So hopefully you will get the same thing I got, which was $21,926.47. Okay, so that's what you should have got if you did that correctly. Okay, all right, so that's the first question. Second question, I'm just going to fix my 9. I don't like the 9 here. Okay, so 9. Okay. Second question. So that is the initial value of the loan. So she must have went in to the bank 4 years ago and said, I need $21,926, please. That's what they lent her. Then she started to pay off $500 every month for the next 4 years. How much interest did she pay after those 4 years? So we need to figure out what the difference is between how much she paid $500 out of her pocket, $500, 500, 500. How many times did you do that? 48 times. So what she's doing is she's taking, so this was part A, okay? It could be here. So for B, the first thing you're saying is she's making $500 payments, and she's doing that 48 times. Okay, so 48 different times she took $500 out of her pocket. Okay, so in total, after this 4 year period, how much money came out of her pockets? What's 500 times 48? 24,000. Okay, so what came out of her pocket was $24,000. But what was her loan amount? Right? Her loan amount was only 21,926. So what's the difference? Whatever that difference is, that $3,000 some odd difference, so 21,926.47, that difference, $2,073.53, is the interest that she paid. It's the cost of borrowing. So you're going to subtract the amount you found, 926.47, and you're going to say, okay, then that means 2073 and 53 is the interest that she paid. That's not a bad amount of money. That's actually pretty good. Interest paid. That's her cost of borrowing. Okay. Very good deal to be able to borrow $21,000, and all you have to pay them as a sort of a thank you is $2,000. That's not bad. Okay, so that's part A and B. Those are very straightforward questions. Now, number C is interesting. And I'm just reading it. I wish I didn't say 2 years, because what I want you to do for a second here is, I'm going to open a new page. I want you to think about a timeline. Okay, so you're starting your payments and it goes on for however many years. Now, in your timeline, let's assume that, so this is today, so this is 1 year, 2 year, 3 year, 4 years. Okay, each year you're paying a little bit off. Remember when I showed you this? So your little bit goes towards principal, a little bit goes towards interest, a little bit goes to principal. So each year she's making these $500 payments, right? Or actually not each year, each month. So within each one of these 4 years, 1, 2, 3, 4, 5, 6, 12 of these, 12 of these, 12 of these, 12 of these. After 2 years, so this is exactly halfway. So right about here, the question C is asking, what is the balance that she still owes on the principal at that point? So I'm asking you, what does she still owe? Remember, she owed $21,926 in the beginning. That was right here. I'm saying, what is she going to owe at this point? So that at the last end of the year, she's going to owe $0. Okay, so what is this balance is the question. Now, the easiest way to do this question is to not to go backwards and go, okay, well, let me figure out how much she paid in here and then subtract it from that. That is a very common mistake that people will make. And without getting into too many details over video about why that doesn't work, it just doesn't work. Okay, it's not as easy as just figuring out, oh, I'm just going to figure out how much she paid in 2 years and subtract it off of what she owed. So instead, what I want you to do is I want you to find the present value at for the remaining amount of time. So I want you to just take the same formula, PV formula, but you change your N to the time remaining. Okay. Now, in this case, it just happens to be 2, which was the same as the time that passed, and that's totally a fluke. Okay, this was 2 years here, and I'm saying this is 2 years here. Even if this was, let's say, a 10-year period, then I would ask you to make the N not 2. I would have asked you to make the time remaining 10 minus 2, and then you would have made n 8. Okay, so I don't want you to just say, oh, I'm taking 2 because there was 2 years, right, in this question here, because the question said 2 years. That's not why I'm putting 2 in. I'm putting 2 in because it's the period remaining. So I would have put 8 in if it was 10. I hope you understand that. Okay, this is the only way it's actually going to work. So I'm going to take, let me just open a new page here. I'm going to take all the same parameters. So PV is what I'm looking for. My interest rate is still 0.6% divided by the 12 months. My N is now 4 minus 2. So 4 minus the balance, which we said was 2. And then my, what else do I have? PI, and I need my payment, which was my R, and that's still 500. So everything else stays the same, but just plug all this into your new formula. So it's going to be 500. And then your formula was 1 minus 1 plus point, oh, sorry, I think it was 4.5%. I had 6%. My bad. It should be 4.5%. So 0.045. Okay, 0.045 divided by 12, and then change it to negative. In this case, I'm making it 2, and then I'm going to close the bracket. Okay, so plug all that numbers into your calculator, and you should get $11,455.32. Okay, so double check that you got the same number. And if you don't believe me about what I said earlier, this number is not going to be correct if you chose the number. If you had chose where's the here this timeline? If you had chose this number of years, the number of the years that had already passed, it will not give you the same answer. Okay. All right, so that answers C. How much did she pay? How much was paid towards the principal after 2 years, and how much was paid towards interest? So this is actually a really good question. Remember on that spreadsheet? Actually, let me show you the spreadsheet again. This part D and part E is asking you basically this breakdown. Remember so let's look at payment 37. You paid $674 in cash. Here you go. You gave the bank that. What did they do with $674? Part of that 674 went towards the principal, part of it went towards the interest. That's what I'm asking you to figure out for the Kate scenario. I'm asking you to figure out how much of the total she paid in 2 years went towards principal and how much went towards interest. Okay, so let's do that right now. Now, what we have to first figure out is how much did she pay in total? And I think we figured that out already, right? We did the 500. Oh no, we actually only did 500 times 48. In total, in the 4 years, $24,000 came out of her pocket. But in 2 years, so in 2 years, so total, it's actually what I'm going to type this because it's quicker to type. So total paid in 2 years, okay, is how much? So $500 came out of her pocket, and she did it for 24 payments, right? Because 2 years is 24 months. And so that is just a quick calculation, $12,000. Okay, so $12,000 is what she paid out of her pocket. How much did she pay towards the principal? So if we take the total principal that we knew, so the total principal, and we subtract the balance that we just calculated a minute ago, the balance after 2 years. So the total principal, if I remember correctly, was $21,926.47. And if we take away that balance, so the balance we got was $11,455, right? That's the remaining principal. Okay, so that ends up being $10,471 and how much? 15 cents. Okay, so your total principal that she owes minus the balance that you just figured out in the previous question is $10,471. This dollar amount is what she owes, for principal. Okay, so that's her principal owing. Total principal. Sorry, that's how much she paid towards the principal. Okay, total principal minus the balance she owes is the amount that she paid towards a principal. So if I go back to the spreadsheet, it is like this number right here. It's the amount that was paid towards the principal. Okay, now how do we figure this number out? Take the total amount she paid, that's that 12,000, and take away this number right here, right? Because this number plus this number equals this number. Or this number minus this number is going to be equal to this number, right? Doesn't matter which order you went in. So we're going to take the total paid answer that we had here, the total paid in 2 years. So this is actually, technically this is answering, this was actually amount she paid toward. This is actually answering D, and now we're answering E. How much was she, total she paid in 2 years was 12,000, and you're going to subtract the total paid towards the balance, towards the principal, which in this case is 10,000. So $12,000 minus the 10,000 that was paid towards the principal, 471.15, and that's how much in interest she paid in 2 years. 28. Okay, so 2 years, so that scenario here, 1,528, that's right here. In interest, she paid 1,528. In principal, she paid 10,471. So that's good, right? That means that she's paying more towards what she borrowed the money originally for than giving them a bigger tip, giving a much smaller tip, $1,528 tip in 2 years, but 10,471 was towards the principal. Does that make sense? I hope so. If you're confused and you want me to kind of go through this one-on-one with you, please join me during office hours. I will put a video solution for this Ariel question as well as this Jenny question if you need help. But otherwise, it's just a matter of plugging the numbers correctly into the formula. And then I'll also post a written solution. Okay. All right. I'm going to stop here and come meet me during office hours if you need to.